Our next speaker is going to be Ambat Vijayakumar. He's coming from Kerala and talking about mathematics is everywhere and attempts to encourage creativity among the students. The teachers in New Zealand kept the sorting network on the floor in her elementary school classroom all the time. It's very durable. The students walked on it and sorted on things spontaneously. For example, questions in history or science, or even discussions that they wanted to make a decision about events in their classroom. They would meet and have a conversation and then meet the next person and have a conversation about some event in their classroom. So it's very useful just to have it laying around all the time.
Okay, thank you very much. I am from Kerala. This is what I am going to say. So thanks to computer science, I could say that mathematics is beautiful. I could show the Mandelbrot set, which is an example of a fractal, but for computer science, I could not have done that. So I thought of congratulating these two young Indians wherever I go, at least for next 1 year. So I think you know both Manjul Bhargava and Subhash Khote, who came into prominence in the ICM 2014. Okay, so this question is not mine. I heard this question in some international forums like International Congress of Mathematics Education. Should mathematicians communicate to the society at large? If so, why should mathematicians talk to others, and how should we do it? The other question was, where are the future mathematicians? Are they still around? So these are all projects on the pipeline from my friend from Australia. And the first question is, should we talk to mathematicians at all? I mean, mathematicians should talk to others. So I feel that mathematicians should communicate, and the method by which I try to communicate is to write articles in my language. I will tell you the readability of this article and so on. Where are the future mathematicians is that, what are the school students doing after taking their +2 studies? Are they opting a career in mathematics? Are they studying mathematics at all, or are they all of them are going to engineering or medicine? So this is a international discussion taking place where we have data from 6 to 10 countries, but not from India. I tried my best, but I could not get it. So something is happening in this part of Kerala near Cochin. This Paravur is a constituency. We have legislative assembly with 140 people, and this Paravur is a place near Cochin where something is going on. We have a project called SASTRAYAAN, in which about 7,000 students in class 8 and 9 are involved from 21 government schools and aided schools. Will participate in a unique program aimed at making science learning a meaningful experience. This is a project initiated by the local MLA, Mr. Sadishan, who is basically an advocate. Our Chief Minister was quite excited, and I have asked other members of the Legislative Assembly also to follow Mr. Sadishan. So the idea is to make science learning more activity based. So this is the project I am taking the class. So Paravur is a rural area which is where economically backward people are there, especially fishermen community. The students are from very, very poor background. So we are showing them some science and some mathematics. So the idea is, there are 5 components in this program called Shraddha. Shraddha means extra backup and special thrust on curriculum based learning. The other is Mitra, 3 to 5 schools having a guest lecture. I am involved in this Mitra project. And Suvidha. Suvidha means giving all facilities, infrastructures for the schools. And Vidya, special training for teachers and the most exceptional students. And Kriya. Kriya means actually doing the exhibitions, projects, competitions, and community based programs. So this was launched on 17th December 2011 by the Honorable former President of India, Dr. Kalam. And we have now the Space Pavilion, Science Park, Energy Park, Herbarium, Aquarium, Butterfly Park, and Astronomy Club in the 21 schools in that constituency. Several of us collaborate. All these are government-based institutions, starting from CDIT, BPCL, Kerala Forest Research Institute, etc. And this is the new object which has come in that school. So let us see. A school boy from a rural area is seeing this object every day morning. And the excitement that he gets and the inspiration that he gets by seeing this model, MALAYALAM project of Government of India, Indian Space Research Organization, was a great success. And the students are seeing this object every day morning. So this was inaugurated last month by the chairman of the Indian Space Research Organization. So this is a famous picture which I found somewhere else. They have an image problem to solve. So this is the basic problem with the school teachers. And this is the image that the students have about their school teachers. Unless you answer, I will shoot you, like this. So this survey was conducted in several countries, and most of the students drew this picture of their mathematics teacher, which is something exciting or surprising. And this is the usual question that we get. If you take a mathematics degree, what can you do with the math degree? So this is the poster of the American Mathematical Society to describe that there are several opportunities for a student if you take up a career in mathematics. So this is a project of the Government of India, where the Robert Canigal's book has been translated into 6 languages so far, including Malayalam from Kerala. I think Tamil version has not yet already come. Okay, National Book Trust. Okay, so this is the Srinivasa Raman's house which I visited last month. So whenever I get excited, my idea is to share this excitement with the students. So I have written an article in English which is coming in the January issue of Science India. Okay, so this is another article which I wrote. Now why should I write articles in Malayalam? This is the reason. Malayalam Manorama is a paper which has got 2.2 million copies thrice a week. I repeat, it has got a student pull out which contains 2.2 million copies thrice a week. So roughly 6.6 million copies of this pull out is being circulated throughout India and abroad also. And most of the students in the rural areas, especially those who are studying in Malayalam medium, are reading these articles. And these articles are cut out from the paper and put on the notice board also. So I have written at least 50 such articles on various aspects of mathematics to take them away from their conventional school textbooks and see that these are the mathematics that you see all around. It is everywhere. So I will show you 1 or 2 articles which I wrote, and this question is just a philosophical or a controversial question: is mathematics an inherent part of our reality or not? So I am not going to discuss this point now. Okay. 786. I think you may not also know. 786 is the thing which you find in the entrance of a mosque. Okay. Now I asked a lot of my friends from Muslim community, what does this 786 represent? Nobody was able to give an answer, so I thought of finding it myself, and I found it and I wrote an article a couple of years back. So 786 is actually the numerical equivalent of the first sentence of Holy Quran, Bismillahir-Rahmanir-Rahim. Okay, how do you do that? It is in the abjad numeral system. This numeral system is not there. Our binary, just like our binary and decimal. So what is done? Each alphabet is given a number. Okay, in Arabic language, alif is the first alphabet. So alif gets A, B gets 2, etc. So Bismillahir-Rahmanir-Rahim, you are taking numbers to each alphabet, which is same as the Katabayadi system which was available in Kerala, ancient Kerala school of mathematics. Okay, what do? We have Malayalam alphabets and you assign a numerical value for that. So if you have Bismillahir-Rahmanir-Rahim, a sentence, and you follow the abjad numeral system and add up all these numbers that have been ascribed, what you will get is 786. Now why should I tell this in a school where I am not going to propagate Quran or something? What I have interested is 786 is a Sphenic number. This is the article which I wrote in 2009 about 786. Okay. My co-author is a PhD student in IIT Bombay now. Okay. So, this 786 turns out to be a Sphenic number. Sphenic number is a number which has got exactly 3 prime factors. Okay. So, the 786 can be factored into 2 into 3 into 131, and this is what I try to do just by showing linking 786, which is a number which you find in the entrance of a mosque, to a number which is interesting for number theories, namely Sphenic number, which has got exactly 3 prime factors. Your Ramanujan number 1729 is also Sphenic because it is 3 into 7 into 13 into 19. Now come to this. This is the famous 36 officers problem. I will tell you about that problem in 1 minute. The solution of which was done by 2 Indian mathematicians and an American mathematician, R.C. Bose, Srikhande and E.T. Parker. Unfortunately, nobody means no school student, even serious student, have not heard the name of Bose and Srikhande, who are the key figures in the coding theory. BCH code that we have, Bose, Chowdhury and Hockengam God has B coming there, and Srikhande name is there throughout in the statistical design theory, combinatorial design theory. But unfortunately, Srikhande is not known to any of the school students. How do we make him known? The easiest way was to write an article about his wonderful contribution of solving the 36 officers problem of Euler. Okay, so Euler's problem of 36 officers is in the theory of Latin squares. The students have seen or heard about matrices, and all that we have to do is to tell them that Latin square is a special case of a special type of a matrix. And this problem can be understood by any 6th standard or 7th standard student. Can you arrange 36 officers from 6 different regiments of 6 different ranks in 6 by 6 array, so that each row and each column contains 1 officer of each rank and 1 officer of each regiment? So, this 36 creates a trouble. That's the point. Okay. So, had it been 16, I could have very well done like this 1 2 3 4 2 1 4 3 3 4 1 2 4 3 2 1 of regiments, and 1 2 3 4 3 4 1 2 4 3 2 1 and 2 1 4 3 of officers. I can solve this problem of 16 officers by the theory of mutually orthogonal Latin squares. Okay. I won't tell the students that it's a theory of mutually orthogonal Latin squares, then they will run away. Okay. So, all that they have to do is to keep 2 sets of people 6 by 6 and try to do that, and they cannot. That is what the point is. So, because 6 is 3 into 2 and there is no mutually orthogonal Latin squares of order 2, which is 1 into 2, poor Euler felt that there is no possibility of having a mutually orthogonal Latin squares of order n when n is an odd multiple of 2. I repeat, there is no mutually orthogonal Latin square of order 2. There is no for 6 because 36 officers problem could not be solved. So, Euler thought that for any value of n which is an odd multiple of 2, there is no pair of mutually orthogonal Latin squares. Unfortunately, Euler was completely wrong, and not only that, R.C. Bose, Srikhande and Parker did was, except for n is equal to 2 and 6, they could construct a pair of mutually orthogonal Latin squares. They are called famous. They are famous under the name Euler spoilers. Okay, so they are called Euler spoilers. 3 people are there. The person who is facing us is Srikhande. He is very young. He is just 97, and he is still alive, very active. Okay. So, Bose passed away and Parker also passed away, only Srikhande remains. Okay. This I would spread wherever I go. Calculus was born in, though the discussion is mathematics outside calculus, I will spend 1 slide for this. Calculus was born in Kerala, where we have a Kerala School of Mathematics from 1350 to 1650. So, whenever I go abroad and tell this, especially when we have audience from Germany, they are a little bit reluctant to accept this. The British accept, and there is no problem. Okay. So, what is the way to give them a proof? Easy method is to suggest 3 books. One is The Crest of the Peacock by George Gevorgis Joseph, which is a publication of the Princeton University Press, and the other is 2 classics. One is from Kim Plofker, the mathematics in India. Kim is a professor from US. I think JAM has written an article reviewing this book in the latest edition of At Right Angles. Okay. So, the other one is by an Indian author, Kerala author, which is not well known, the golden age of Indian mathematics. So, the golden age of Indian mathematics was actually the golden age of mathematics in Kerala from 1350 to 1650. This is another poster about mathematics in India. I think Venkatesan has a copy, and all of us have been to National Initiative on Mathematics Education led by JAM and others. We are all part of that movement. Okay, this is the question which I also ask my school students. How does Google? What is the science of search rankings, etc. So, I have also written an article on this. You know, the PageRank algorithm uses the matrices, isn't it? The eigenvalues. So, when I go to schools and ask them, why are you studying eigenvalues and eigenvectors? Obviously, they do not have answer. They do not know how to use it or where to use it. So, this is how I could bring in some creativity by asking at least some good students, and large number of students takes part in such programs, and the readership of these articles in Malayalam is huge, which I told you it is about 2.2 million, and there is definitely an impact among the students to have a rethinking of what they have been doing in the schools. So, the mathematics behind the internet, just to tell them it is linear algebra and graph theory, nothing other than that. And who is number one? This is a very famous book, and based on these two books I have written an article in Malayalam recently 2 months back. So, the science of rating and ranking, which you require everywhere. Okay. So, if you want to give some funds from based on Human Development Index, how do you do that? Okay. How do you rank the web pages? How do you select the number one in a school or a class? Okay. How do you choose your leader in the elections? So, all these places you require to choose number one, and there is a science behind this, and this I convey through my articles. Say for example, Facebook social network analysis, how do you choose all these things? So, science of ranking, and this is the article which I wrote on this paper, which is about Onnamane Kandathan, means how to find the rank number one. Okay. So, the message that I wanted to convey to you is that by writing articles in Malayalam, I am very, very happy that students read it. Several people ask me why can't you write in English, and that is not my mission, because there are many people writing articles in English which will not reach the rural students in Kerala. So, I have to write it in Malayalam, and I am very happy that the project has been a success. Another thing which I read was about Shannon's coding theory and entropy, mathematical theory of communication. I have written an article on this. This is there is an Inspire camp by the Government of India Department of Science and Technology. So, this is my pet slide. Can you read this? Yes, you can, isn't it? So, only the first alphabet and the second alphabet need to be fixed to guess the possible word, because it is written in English. Okay. So, if you can read this, you have a strange mind too. Can you read this? You can keep on reading. There is no problem. So, these students are really excited, and I cash their excitement. That is what I am doing. And about the origin of WWW, the World Wide Web, a famous quote from popular science writer Arthur Clarke, who predicted World Wide Web in 1970. And Tim Berners-Lee did it much later in 1989 in the CERN lab. So, popularization of various. So, why are we worried about these things? Because we may need a new mathematics to explain the working of the networks in the information age. So, because there are huge number of websites, and we require a new mathematics to understand, and that is what some of us are doing in my research. One of my research areas is what is called the networks or scale free phenomena, where we come across such networks. So, I will show you some of my article. This is about what is graph theory. Okay. There is a children's magazine called Kalikuduka, Tiny Tot, where you have to find the way to reach your house. This is a famous puzzle that you find in almost all children's magazines in India, right? You start from one point to another, you have to find the route to go back to his school, or to his house. right. So, you can try to find a route to help him find a route to the techniques of graph theory. Okay. So, this is about 4-color problem. Okay, it is all written in Malayalam, and yeah, this is something about, look at the picture, head upside down. Okay. So, even if you turn upside down, there is nothing going to happen if you have a palindrome, right. So, this is an article about palindromes. So, the students are really excited to see such a figure head upside down, and they definitely spend time to read such articles, and in the classes also such discussions takes place. Oh, this is about pi 3.14. There are several stories that you can tell about pi. This I wrote about 2007. And this object, though it is a chemical object, it is a molecule, what we call the Buckminster fullerene. There are many things that you can talk about this in mathematics also, right. It is a graph in which each face is a pentagon or a hexagon, and to study the stability of the molecule, now this is at the hand of mathematicians or graph theorists. Fan Chung from UCLA, University of California, Los Angeles, she is an expert on this. She studies this object through what is called the automorphism group of a graph, and how best can she say about the stability of this molecule. When chemistry people found this, they got Nobel Prize. When physical properties of this molecule was analyzed, they also got a Nobel Prize. But unfortunately, mathematicians cannot get a Nobel Prize for any discovery, but they have some equivalent medals and so on. And this is thing which I have written at least 2 articles on this Collatz conjecture, your 3n plus 1 problem. I suppose you know that. It is a mapping from n to n, natural numbers to natural numbers. If n is even, you put n by 2, and if n is odd, you make it 3n plus 1, 3 times n plus 1. Okay. If it is n is even, it is n by 2. If n is odd, it is 3 times n plus 1. And this is a famous Collatz problem which was posed at least 60 years ago to show that 1, 2, 4 is the only circuit in this thing. Okay. If you reach 4, you get 2, okay, and 2 gets to 1, but 1 is mapped to 4 again. So, whatever be the number that you are going to start, you are finally end up with only one circuit, namely 4, 2, 1. Okay. So, when you try this with n is equal to 27, this is an example. Okay. So, you start with n is equal to 27, which is 27, it is odd, it goes to 82, 3 into 27 plus 1, 82 is even, it comes to 41. So, at each step the student have a feeling that maybe they are seeing such a problem for the first time in their life, a problem which a student cannot solve. Okay. If you look at the textbooks, all the problems that you see is that all the problems can be solved. So, they have an impression that all problems are solvable. So, at least to create a creativity or interest in the subject, I gave n is equal to 27. You know, n is equal to 27 behaves very mad way. It reaches up to 9, 2, 3, 3, 2, okay, and starts coming down. And when you reach 8, all of us are happy, or 16, we are happy. 16 comes to 8, 8 comes to 4, 4 comes to 2, 2 comes to 1. Okay. So, n is equal to 27 is an example which you take lot of time, right. So, the students have a feeling, as I repeatedly say, students have a feeling that okay, all the problems are easy because the problems that you get in the examination question papers are all easy ones, or if you see in the textbooks, they are all easy. Such crazy or mad problems are not there in the textbooks. So, I use this facility to propagate such problems. Okay, this is the famous mark list of Ramanujan thanks to AMTI. Yeah, this I will take 1 second. I participated in the MENAO program of ICM, organized by International Mathematical Union in the ICM held in Seoul, August 2014. So, one of the key point of discussion was MENAO. MENAO means Mathematics in Emerging Nations, Achievements and Opportunities. There were about 400 participants. In fact, Professor Keshavan from IMSC was the head from India. So several countries, developing countries, developed countries participated in what best so-called developed countries can do to make the mathematics education or general education more interesting and reachable. Okay. So some of us have joined in this project to serve some other part of the world by going there for a month. Okay. It's a program of the International Mathematical Union. We have an INSPIRE program by Government of Science and Technology, Department of Science and Technology. Innovation in Science Pursuit for Inspired Research is a program which is generally very generously funded by the Department of Science and Technology. And this is the largest audience that I have addressed school students. Okay, it's about 700. So this was done in an engineering college in Kerala under the banner of INSPIRE. And what happened was, when I finished my talk, the other person could not get time for his talk because the discussion took place for another 2 hours. So that happened somehow. And there are some popular magazines, one from Association of Mathematics Teachers of India called the Mathematics Teacher, and then another magazine which I want to propagate is At Right Angles by Asim Premji Foundation. This is freely available, anybody can register and get a copy. Okay. So Merry Christmas and Happy New Year 2015. I am doing a little bit of PR for our Kerala Tourism Department. So those who have not come to Kerala or Cochin, of course, Mike and Fran has come at least 2 times. So welcome to Kerala and Cochin, especially during August. If you come, you can see such things. Even otherwise, if you come any point of time, I will show you this. Okay. So thanks to Jam and others for giving me an opportunity to say something about what is happening in Kerala. Thank you.
Thank you so much. Are there any questions? It's a beautiful talk with a lot of resources.
Okay, thank you. Yes.
Matt?
I think it's a wonderful opportunity when some of your publications, particularly those aimed at teachers and students, might be PDF'd and put out on the web. So my question is that possible to have some of the publications made sort of more accessible beyond just print-based?
Yeah, you mean put it in the web? Yeah, it's possible. I have not tried, but I will do that.
Particularly those in English.
Okay.
I'd struggle a bit in other languages.
Okay, thank you.
Jim, are the slides going to be available? Oh, that's wonderful. Slides will be available.
Only thing is the speakers have to sign a consent form to make sure that everybody can.
Okay, I may give an edited version of this, not all slides. Okay. Especially something which relates to one of my mentors. I want to avoid this. This is the former President of India who gave us the confidence to say more on popularizing science and mathematics. And my mentor for this such type articles is Robin Wilson from Open University, Milton Keynes, UK, who has visited Kerala, my university several times. And whenever I go for such popular talk, I send him a mail saying that, Robin, I am going to give a talk somewhere. So I did for this conference also. And he is, along with Ian Stewart, he is the person who has given maximum number of popular talks in the entire world, maybe of the order of 2,000 or 3,000. And Ian Stewart is the other person who has done the similar job. Okay, thank you.
Thank you. Of that amazing mathematics playground out behind this university?
We have a Center for Science in Society. I forgot to tell that, thank you, where takes care of, as she said, she has been to that place. In Cochin University, we have a Center for Science in Society for school children to come and play and learn mathematics and science. Thank you.
They even have an auto rickshaw with a plastic cut in half so you can see inside how it works. Then the children can actually start it up and make it work and you can watch it. Fantastic.